What is a buffer flow attack? A buffer flow attack means buffers are memory storage regions that temporarily hold data while it is being transferred from one location to another. So, when a memory is transferring from one location to another, there is a buffer memory called buffer. So, at that time, when a memory is increasing itself, then it causes an overflow. So, with that overflow, there are several serious reasons that an attacker might steal our data and etc. So as a result of the program attempting to write the data to buffer overwrites adjacent memory locations. So the basic adjacent memory locations are come under the overflow regions. For example, a buffer for login credentials may be designed to expect a username and password input of 8 bits. So if a transaction involves input of 10 bytes, the program may access the data past the buffer boundary. So for any buffer memory, there is a certain limit. After that limit reaches, then it goes into an overflow region, so that lead to the excess of memory and lossage of data. Buffer flow can affect all types of software. They typically result from malformed inputs or failure to allocate enough space for the buffer. If the transaction overwrites executable code, it can cause the programs to behave unexpectedly and generate incorrect results, memory access or crashes. So due to these overflow attacks, the excess memories and the previous memories are always have always generate incorrect results and the memory errors or crashes. So this leads to the effect of program and cannot be worked properly. So generally, a buffer attack occurs when a program is overwriting of the memory of an application. So when an application memory is overwritten by some other person, then it leads to a buffer flow attack. This changes the execute path of the program, triggering a response that damages files or exposes private information. So when a memory is exposing itself, when a memory is overwriting itself and exposing, then the execution path of the program triggers to damage files and expose private information. For example, an attacker may introduce an extra code sending new instructions to the application to gain the IT system. So whenever a person with a malicious threat intent, so he intentionally sends some extra lines of codes or sends some extra malicious information to to get a bait and gain some information. So there are several types of buffer flow attacks like stack based buffer flow attacks and heap based overflow attacks. So stack based is generally most common and leverage stack memory that only exists during the execution time of a function, whereas the heap based attacks are harder to carry out and involve flooding the memory space allocated for a program. Common languages are like C, C++ are highly susceptible to buffer overflow attacks, and they don't have any safeguards against overwriting and accessing memory. Mac OS, Windows, and Linux all use written in a C++. So which are the programs written in the C++ or C codes, it is easy to do see buffer flow. It is used to attacks while with the usage of buffer flow. Next, languages like Perl, JavaScript, Java, C hash are used to build safety mechanism to minimize the likelihood of buffer flow. So, to prevent buffer flow attacks, these buffer developers can protect against buffer flow vulnerabilities via security measures in their code by using languages that offer built-in protection. So, for examples like Perl, Java, and JavaScript, these are some safety precautions and can give the code directly can give access to some authorized persons. So by that we can prevent these buffer flow attacks. In addition, modern operating systems like that have runtime protection, these common protections are address space randomization, ASLR. So randomly moves around the address space locations of data regions. So when a buffer flow is when a memory is recording in the buffer, so it randomly places the memory rather than periodically. Typically, buffer flow attacks need to know the location of executable code, randomizing address and specs. So wherever it places, it must locates its index values and the address where it's storing. Next, data execution prevention. Flags certain areas of memory as non-executable or executable, which stops an attack from running code in a non-executable region. Structured and exception handler or protect SCHOP helps malicious code from attacking structured exception handling built-in system for managing hardware and software exceptions. So with this these security measures in code and operating system protections are not enough when an organization discusses buffer overflow. So it must be read quickly and patch affected software. Make sure that the users provides access the patch. So buffer flow overflow attack is an intentional threat to a software.